In this video, we're going to look at the key attributes and methods that attach to a NumPy object. So if you recall the previous video on the Python list, the one on object-oriented programming, we talk about basically everything in Python are objects. So just to recap, what is an object? You can think of an object just as a thing in everyday life. For example, your laptop is an object. So there are certain static components or attributes that you have on this laptop, such like its color, its brand, and all of its specs. These are all static attributes. So it's the same thing in Python objects. We have these attributes attached to that, such as the shape of this array and the number of dimensions that this array has, etc. On the other hand, you have the dynamic components of your laptop. It can be switch on, switch off. You might just maybe turn the fan on, or you might have a GPU and maybe accelerate with GPU, or these are dynamic components. So this is like functions, and in an object we call it methods. So methods are just functions that's attached to a specific object. So the aim of this video is just to go through some of the most important attributes. There are quite a lot of them. I can't go through all of them, but pick some of the most important attributes and methods, so you can be aware of what's available out there. Okay, so in the last video we talked about NumPy arrays are mutable objects. So if you just assign an object to another, they're basically the same thing. So you change one, you change both. So if you want to make an independent copy, you need to use the copy method. So that will just clone the original data to another memory address, so that you can just change one without worrying change both. So if you look at the ID of array 2 and array 3, that gives you the memory address. So you can see they're different. One is 484, one is 192. Okay, so you can safely work on ARR3 change on this without worrying interrupting with ARR2 here. Alright, the next thing, which is quite important, is look at the shape, because we know ARR2 has 2 rows and 3 columns, and we can get that here. We have 2 rows and 3 columns, and if we had a high dimensional array, that would be much longer. It can be 4 or 5. For example, in deep learning, when we work with PyTorch, that's similar to NumPy in terms of the dimensions. You might have the height and width as the image, and you will have the stack if you are working with a 3D image. Then you have the channel, which is like, is it a grayscale or is RGB? Because sometimes you might work with RGB images. And then you have the batch size as the first index. So at the end, you might end up 506 in terms of the length of the shape. So this can be actually assessed using the n dimension. So that will tell you there are 2 dimensions here. So in this case, it's just the row and column, because we are dealing with a 2D matrix. So you can think of what this gives is how many dimensions this array is. So in this case, it's a 2D array. And if you have this data, sometimes we want to reshape it. Reshape just means to change this into another shape. For example, we have a 2x3, but if we want to map that to 3x2, we can use the reshape function. So in the reshape, we put in the new shape. So we can also maybe wrap it to 1x6, that's also fine. But be careful, the number of this, like if you multiply this, needs to be the same as the original size. So when I say size, just means how many elements are there. There are 6 here, so you can't do something like convert this to 1 by 2, 1 by 5, because it's not the same number of elements. So 3 by 2 is totally fine, and maybe 6 by 1 is also fine. Or you can, it doesn't need to have the same dimensions. You can 6 by 1 by 1 by 1, that's also fine, as long as the number of elements matches. Okay, the next one is an attribute. We can look at the D type, data type. So we talked about this earlier. So in this case, AR2 is integer 64, so you don't see a dot if it's integer type. And we can actually convert this using the S type. So that will create a new copy of data using this new type. So we can convert it maybe to float. I need to specify 16 or 32. There's no data type, just called float. So in this case, it would tell you the data type is float 16, which is single precision float. Double precision would be 32, and the heights will be 64. In some cases, it might support 1 to 8. So you can see there's a dot if it's a float. Okay, the next one is for stats or simple understanding of the data, the range, and etc. We can have the max and the min, and also the mean, the average, and we also get, I don't know whether we have median attached with the object. Okay, so some methods are not there, but it's inside NP. You can call it as a function and pass your array as the argument. So that will give you the median. So for example, this min, you can also do np.min. So that's the function under np, and you pass array2 as the argument. If it is as commonly used, I think Numpy just put it inside the array, so you can just call like this. But median probably is not that commonly used compared with min and max, so that's not inside the array, but it's implemented under Numpy as a function. So this is a good contrast between what is a function and what is a method. This is a method because it's attached to the array. Okay, next thing is clip. Sometimes, for example, when you read in a CT, you want to maybe just clip it between -1000 to 1000. So clip is something you can do. You can just put a number. So if we clip it, so if we just put in one number, that would be the minimum. Let's bring up the original AR2 is this one. If you put in one number, that means the lower limit needs to be 4, so the 2, 3 will end up as 4. And then if you want to put a higher limit here, maybe put in 7 here. So notice the 10 here will be clipped to 7. So this is how clip works, and it's quite useful. Next one is round. So if you want to round something, in this case it's not very useful because it's already integer. Let's make it maybe plus np.random.rand 2 by 3. So ARR3 should be a float. And then we can actually round ARR3. So that will round it to the nearest integer. So notice 4.7 is round to 5. and then 2.5 is 1 to 3. 6.2 it's not greater than 6.5, so that's why it's run to the floor rather than to the ceiling. Okay, the next one is to convert NumPy array to back to the list. So there's a bunch of these two methods. So there's to list, there's also to string, for example. Also, it's deprecated, so to use 2 bytes. So that will convert it to the raw byte. You probably don't need to use this very often, but sometimes when you say modify some image information in NumPy array, you put it back into the DICOM file, you need to convert to bytes before you put it in. But just be aware there's some functions like this. So this wrap up this video. So with all this, you have more tools to deal with NumPy arrays.